Today, our focus is parallelograms. And like the name suggests, opposite sides are parallel. That's how it, so AD and BC are parallel. A, AB and DC are parallel. Opposite sides are congruent. So AB is congruent to DC. BC is congruent to AD. Opposite angles are congruent, so angle B is congruent to angle D, angle A is congruent to angle C, and consecutive angles, which remember are side-by-side angles, are supplementary. So these two are supplementary, as well as these two, and these two, and those two. So, if AB is equal to 8, then DC is equal to what? Well, since it's a parallelogram, and we know that parallelograms, opposite sides are congruent, DC also has to equal 8. The measure of AD is 11, so the measure of BC, which is opposite, it has to be 11 as well. The measure of angle 1, so the measure of angle B equals 47. So this right here equals 47. Measure of angle D has to equal what? Well, since we know that opposite angles are congruent, angle D has to equal 47 degrees. So the measure of angle C has to equal, well, consecutive angles are supplementary. So we set 47 plus the measure of angle C equal to 180. So the measure of angle C is 133 degrees. We got some more problems to do. So AD is congruent to BC. Angle A is congruent to the angle opposite, which is angle C. The measure of angle A plus what is equal to 180? Well, there's actually two different angles that could fit here. So it's consecutive angles that are congruent. So A and D are consecutive angles, and A and B are consecutive angles. So since they're supplementary, we can say the measure of angle A plus the measure of angle D equals 180, or the measure of angle A plus the measure of angle B also equals 180. DC is congruent to the side opposite it, which is AB. The measure of angle B is congruent to the angle opposite that, so angle D. So now what we're going to talk about is diagonals of parallelograms. So a diagonal of a parallelogram, which is drawn through opposite angles, divides the parallelogram into two equal triangles. So if we're looking at this diagonal first, this triangle formed right here is congruent to this triangle formed right here. And if we're looking at the other diagonal right here, this triangle right here is congruent to this triangle right here. The diagonals also bisect each other. And bisect, right here, if you don't know what it means already, it means cuts into two equal parts. So if I call this point right here point F, that means that if I'm looking at this lighter blue diagonal first, that this part is equal to this part, or if I'm looking at this dark blue diagonal, this part is equal to this part. So now we're going to do some examples using that information. So we know that triangle BCA, which is formed by this solid diagonal right here, that's going to be congruent to this triangle over here. So triangle BCA is congruent to triangle DCA, triangle ABD, which is formed by this dotted diagonal ABD, is congruent to triangle DCA. So if this right here equals 5, what does this part equal? Well, like we said that when these diagonals cross each other, they bisect each other. So when they bisect to each other, they cut them into two equal pieces. So if this side equals 5, then EC also has to equal 5. So point E is the midpoint of what two lines? The midpoint is literally just the point in the center of a line. And we know that it's a midpoint because the line segments are equal. So point E is the midpoint of this diagonal AC right and this diagonal BD because it cuts this line into two equal pieces as well. So we went over this today so that in the next lesson, when we talk about special kinds of parallelograms, we already have a ground knowledge. So make sure you come watch the next video.